Hi all. Today we are going to learn about the various transmission modes used in computer communication. In this lecture we will learn about serial and parallel transmission modes, synchronous and asynchronous transmission modes. In computer communication, the transmission modes are classified into parallel transmission and serial transmission. The serial transmission is again classified into synchronous and asynchronous modes. Let's see all these four transmission modes in detail in this lecture. First, let's learn what is parallel transmission. In parallel transmission, all the bits of data are transmitted simultaneously on separate communication lines. For example, if you are transmitting an 8-bit data from the sender to the receiver side, we have to use 8 separate lines to transfer 8 bits. For example, if you are transmitting the data 10110100, the 8-bit binary number from the sender to the receiver, each bit is transmitted through each line. This is what is called as parallel communication. So here all the bits are transmitted at the same time. So in general, in order to transmit n bits, n wires or n lines are used. Thus each bit has its own separate line. All n bits of one group are transmitted with each clock pulse from one device to another. That is, multiple bits are sent with each clock pulse. Usually parallel transmission is used for short distance communication, and the advantage is high speed as it is using separate wire for each bit. The disadvantage is, though we are using many wires, the cost is very high. In serial transmission, the various bits of data are transmitted serially one after the another through a single line. It requires only one communication line rather than n lines to transmit data from sender to the receiver. Thus all the bits of data are transmitted through a single line in serial fashion. For example, if you are transmitting the data 10110100, the LSB of the digit will be transmitted first, followed by the remaining numbers. The MSB, the most significant bit, will be transmitted last. In serial transmission, only a single bit is sent with each clock pulse. The internal circuitry of a computer transmits data in parallel fashion, so we have to use some parallel to serial data converter at both sender and receiver sides. The conversion devices converts the parallel data into serial data at the sender side, and the serial data is transmitted and the serial data is received at the receiver side, and this received serial data should be again transmitted to parallel data so that the computer at the receiver end can use it. So in the sender side there will be using a parallel to serial data converter, and a serial to parallel data converter is used at the receiver side. This is how serial transmission takes place. Next, let's see the difference between serial and parallel transmission. The number of bits transmitted at one clock pulse in serial transmission is 1 bit, whereas in parallel transmission n bits. Number of lines required to transmit n bits in serial transmission is 1 line or 1 wire, whereas in parallel transmission we have to use n lines for transmitting n bits. The speed of transfer is slow in serial transmission as each byte is transferred at a time, whereas in parallel transmission the speed is fast as all the bits are transmitted at the same time. The cost of transmission is low in serial transmission as there is only a single wire or single line is needed for transmission, whereas in parallel transmission the cost is high as n number of lines are needed to transmit n bits. The application of serial transmission is it can be used for long distance communication between two computers, and parallel transmission are used for short distance communication. For example, the communication between a computer and its printer. Next, let's see what are the different transmission modes in serial transmission. Serial transmission are categorized into two: synchronous transmission and asynchronous transmission. In synchronous transmission, the data is transmitted in the form of blocks or frames. In synchronous transmission, the data transmission is full duplex type, that is, data can be sent to both directions simultaneously. Synchronization is compulsory between the sender and receiver. In synchronous transmission, there is no gap present between the data. The data is transmitted as continuous block from the sender to the receiver. Synchronous transmission is more efficient and more reliable for transmitting large amount of data. In asynchronous transmission, data is sent in the form of byte or character. The transmission mode used here is half duplex type, that is, data can be transmitted to both sides but only one at a time. In this transmission, we are using some start bits and stop bits with data. For example, if we are transmitting a data, we have to use a start bit to represent the beginning of the data, and we have to use some stop bit to represent the end of data, as we are continuously transmitting the data in the form of bytes or characters. The start bit is usually a 0 and the stop bit is usually 1. Asynchronous transmission does not require synchronization. So these all are the various types of transmission modes. Thank you.